Welcome back to Math 171 Pre-Calculus Algebra. In this video, we're going to talk about solving polynomial inequalities. So I'm going to give you the inequality 2x squared plus x is greater than 15. So the first thing that we're going to do, I'm actually going to literally do it like this, off to the side, is we're actually going to solve 2x squared plus x equals 15. So we'll go ahead and subtract 15 from both sides. And then at this point you can use your favorite method to solve a quadratic, or any polynomial for that matter. In this case, I'm going to go ahead and factor this. So 2x minus 5 times x plus 3 equals 0. So now we get 2x minus 5 equals 0, or x plus 3 equals 0. So add 5 to both sides here, then divide both sides by 2. X equals 5 halves, and then over here, just subtract 3 from both sides, you get x equals negative 3. So now, the trick that we're going to use is we could have stuff going to negative infinity. Something could happen at, negative 3. Something could happen at 5 halves. And something could happen at infinity. So we're looking at everything where both sides of this are equal. And then also include negative infinity and infinity, because something could happen there. So now what we're going to do is pick a number in each of these ranges. So here, I'll go ahead and pick negative 4. So I plug in negative 4 to my original equation. So I get 2 times negative 4 squared plus negative 4. I'm going to put a greater than sign with a little bit of a question mark, or with a question mark over it there. Because now we're going to test to see what we get. So I square the negative 4, gives me 16, and 16 times 2 is 32, plus a negative 4, or minus 4, testing to see if that's greater than 15. 28 is greater than 15, so we're good there. So that tells us that part of our solution is going to be negative infinity to negative 3. We know we cannot include the negative 3 because negative 3, both sides of that equation are equal. And we don't have the ability for these to be equal. If this were greater than or equal to, we'd include that negative 3. And we'll do the same thing with the other two ranges that we have to deal with. So maybe between negative 3 and 5 halves, 0 is a good number to check. So 2 times 0 squared plus 0, checking to see if that's greater than 15. Well, anything squared is 0, and then anything multiplied by 0 is 0. So we end up getting 0 greater than 15. That's not true. So it's not going to work in that range. Then we also have to worry about 5 halves to infinity. So let me get rid of that. And between 5 halves and infinity, we pick a number. I'll just pick 3. And we'll go ahead and test this. So 2 times 3 squared plus 3. And we want to know if that's greater than 15. 3 squared is 9, times 2 is 18, plus 3. Again, checking to see if it's greater than 15. 21 is indeed greater than 15. So we can also include 5 halves to infinity. So that's how we solve a polynomial inequality. In the next video, we're actually going to first look at how to solve rational equations before we can talk about solving rational inequalities.